Hello students, during this presentation we are going to be working on some production control sample problems. Let's go ahead and get started. So first off, I'm going to work some problems that are more applicable to the practical problems, then we'll switch gears over to the day in the life problems. Okay, question 1, using the sales data below, calculate the menu mix for the sushi items below. So over here we have all the various sushi items listed and the unit sales. So perhaps this is for like a week and how many items were sold in the week. So menu mix, we just take the unit sales and just divide it by the total sales. And since we're going to copy this down, we want to keep this total sales reference on line 18. So let's go ahead and throw a $ in front of the 18. Copy that on down and then take the sum of it. All right, question 2. Using the menu mix information from question 1 and the total estimated sushi sales below, estimate the unit sales for next week. Okay, and we're told to round your estimates to the nearest whole unit. Okay, so we're going to come in here and use the round function. And we're told to use the estimated sushi sales, so these are total unit sales, along with the menu mix from question 1. So since we're working on the California sushi roll and they are all in order, we'll just multiply it by that value. And we want this to stay in column E, okay, but we want it to move down, so we're going to leave it off of 7. And then down in this reference, we want it to move over, but we don't want it to move down. So let's throw a $ in front of the 23. Okay, so we've copied that down. Now we copy it over. And each of these are using that round function. Question 3. Using the unit sales estimates from question 2, the standard portioning of cooked sushi rice from question 1, and margin of safety of 20%, determine the par level of sushi rice for each day of next week. Measure your par values in pounds and round up to the nearest pound. So here we're trying to figure out what we should set the par at for sushi for next week. Now, perhaps the sushi has a shelf life of 1 day. And so if we prepare it, or 2 days, if we prepare it, then it can be held over to the next day. So we're trying to figure out how much sushi rice to prepare. Now in doing so, we have to balance the need to have sufficient product, not to run out, but also to minimize quantities to keep it as fresh as possible. We are told to go ahead and add a 20% margin of safety to account for variances in guest count forecasts. So all of our menu items use rice, or at least all the menu items provided in this menu mix. And so because of that, the variation won't come really from a change in menu mix, like people changing from items that use 4 ounces to items that use 3 ounces. More of that variation is going to come from the actual number of guests that stay at the restaurant, that eat at the restaurant. So we need to figure out how much rice to cook, okay? We're also told to measure it in 8-pound, actually just to round it up to the next pound. Okay, so let's go ahead and use the round function. And I think it says round up. Yep, round up. Okay, and now what we need to do is multiply the portion size of rice for each menu item by the estimated sales by menu item, which are right here. So a nice function that we can use to multiply each of those figures and then add them all up is sum product. So we're going to do sum product. And we're going to highlight, first off, this column of ounces. And then down here, we're going to do the projected unit sales. Now, when I highlighted this, you'll notice that here for this field, it only selected values from column E, but up here, it selected values from columns G and H, since these cells are merged. Okay. if we leave it like that, it's going to cause an error. So I'm going to go ahead and run it so you can see what the error looks like, and then I'm going to show you how to fix it. Okay, so we've multiplied each of these values by the unit sales and then added them all up. That right there gives us the total in ounces of sushi rice. Okay, but we're told that we're supposed to go ahead and use a margin of safety when determining how much we need of 20%. So let's times it by 1 plus our margin of safety, which is 20%. Okay. This value, though, is measured in pounds. We need it in ounces, so let's go ahead and divide it by 16 to convert it from pounds to ounces. Okay, and there's our roundup formula. When we hit enter, we're going to get this error. Okay, so it doesn't know how to handle these merged cells. So what you do in a situation like this where it's referencing more than one column is you need to force it to just reference one column. So here we've selected G7 through H17. We just want G7 through G17. Okay, and you'll notice that it's only selecting half the contents of the cell, and that's what we want. Okay, so that's 36 pounds of sushi rice. Copy that over. Looks like we left some dollar signs off because I didn't copy properly. And sure enough, up here we need to keep this reference on column G. Let's go ahead and throw a dollar sign out here in front of G. Okay, now let's copy it over. And everything looks great. Question 4. Using the par levels in question 3 and the on-hand values below, determine the daily production and usage. Rice is prepared in 8-pound batches for production values, round up in 8-pound increments. Okay, so we're not going to just produce exactly the amount that we need. We need to round up in 8-pound increments because that's how large a batch of rice is. So to calculate our produce amount, we're going to take our par from question 3, and we're going to subtract from that the amount that we have on hand. Okay, that would give us a production amount of 26, but then we need to round that up to the nearest 8-pound increment. So to do that, we're going to use round up, and we're going to come in here, and after it, we're going to put it in parentheses. Actually, let's put this inner equation in parentheses. Then we're going to divide it by 8. Okay, close our roundup, and then multiply it by 8. So what that's essentially doing is it's saying, go ahead and tell me how many batches you need, right? So we've taken these amounts here, we've divided by 8. That tells us how many batches we need, and we're rounding up to the nearest batch. And then we're multiplying it by 8 to convert it back into pound increments since we're measuring all this in pounds. All right, there we go. We can go ahead and copy that through Sunday. Okay, the other thing that we need to do is to calculate the amount of product that was used. You'll notice that this is only through Saturday because we need to know the amount that is on hand the next morning in order to calculate the amount that was used. So to do this, we're really just using kind of a variation of the formula that we use to calculate cost of goods sold. So normally we would think of cost of goods sold as the amount purchased, product purchased, right? But in this case, we're counting things in units instead. So we come in, we have 10 pounds of sushi rice on hand. We produce an additional 32. That means we have 42 total pounds ready to go at the end of the preparation process to be used that evening in the restaurant. Come in the next morning, we only have 8 on hand. So once again, it's just this kind of beginning inventory plus purchases, which in this case is produced, minus ending inventory, which is the beginning inventory of the next day. And that'll give us the amount that we actually used. So beginning inventory plus purchases, which in this case is the amount that we produced, minus our ending inventory, in this case the beginning inventory of the next day. Okay, we can now copy that sideways that will let us know how much product we used. We could then compare that with how much product we should have used based on our actual unit sales and come up with a variance that would describe how much product that we're missing. Okay, we might not go through all that effort to track rice, but if this was something much more costly, like in our next example, ribeye steaks, then we very much would want to keep an eye on our products and track them, make sure there's no theft or waste going on with those products. All right, question 5. Edwards Steakhouse brines their steaks in-house a day prior to serving them. The steaks need to sit at least a full day prior to being consumed. Using the forecasted demand below, determine the ribeye par values using a margin of safety of 20%. Round values up to the nearest steak. Assume that each week follows the same demand pattern. Okay, so what does all that mean? Well, here on Monday, I've got to have enough product prepared not only for Monday, but for Tuesday as well. That way, by the time Tuesday rolls around, that extra product is still on the shelf and can be used for that day's demand. So really, on Tuesday, then, we'll be prepping the items for Wednesdays is kind of a way to think about it. Okay, we also need to factor in a margin of safety of 20%. So what we're going to do here is we're going to round up to the nearest steak, and we're going to add these two values together. So Monday's demand plus Tuesday's demand. Okay, and let's go ahead and throw that in parentheses. So I'm going to throw another parenthesis out here out front, and then we're going to times it by 1 plus the margin of safety, which we're told is 20%. Okay, and close all our parentheses. That'll round to the nearest steak. So we need to prepare 60 steaks for, or at least the par is set at 60 steaks for Monday. And we'll pull that on through to Sunday. Now you'll notice Sunday is trying to add in this blank cell here. Well, we're told that we should assume that each week follows the same demand pattern. So we can go ahead and use Monday here as the value that we're going to add. Okay, that's it for the sample practical problems. Let's shift gears here now and go work on some sample day in the life problems. So here in question 1, it states, calculate the menu mix for the menu items listed below. Determine the average items, the average number of items guess order. Okay, so here we're going to do the same thing we did in the practical problems. Calculate our menu mix, so that's unit sales divided by total unit sales. Okay, and we want to copy this down, so let's throw a $sign in front of the 16. Okay, the other thing it asks us to calculate are the average items per guest. So how many items is each guest ordering on average? Okay, well, we have 3,165 items being consumed during this period and 1,300 guests. So if we just divide the total items by the total guests, that will give us each guest consuming 2.43 items. Okay, question 2. William operates his American Dogs food trucks Tuesday through Thursday. This gives him and his staff some consistent days off and allows a better work-life balance. The exception to this is if there's a catered event or large social event that William plans on participating in. For the upcoming week, William does not plan on attending any special events. After analyzing his past 4 weeks' volume, he has created averages for the distribution of weekly guests by day. This is labeled daily guest count share below. William has been trending up over the previous year by 8%. Using the information below, help William create a daily guest count forecast. Round your figures to the nearest guest. Okay, so this really involves kind of 2 steps. The first step is to take our previous year's weekly guest count and increase it by 8% to forecast what we think this week will be like. So let's go ahead and do that. So we take the 1,300 and we times it by 1 plus our growth rate of 8%. Okay. And let's go ahead and show what that would be, kind of as this first step. So 1404. So we expect guest counts to go up from 1300 to 1404. Now what we need to do is take this total weekly forecasted guest count and distribute it among each of the different days. So we have 5 days, and we can see how much each day contributes to this overall weekly sales. So we're just taking this and splitting it up based on these weightings, okay? So we also need to round to the nearest guest. So we're going to use round, okay? And let's come on in here, and now let's multiply this by this percentage here. Okay, now as we copy this over, we will want this blue cell to move over to Wednesday, but we want these two cells to stay on column F. So let's throw a $sign out in front of our two F's here. Now we can copy that through Saturday. Okay, so let's talk about what we've done so far. In the PowerPoint for this lesson, I provided you an overview of the restaurant production process. So we're going to follow these steps as we go through this analysis. The first step is to create a daily guest forecast by meal period. Okay, daily guest forecast by meal period. Well, that's what we just did right here. We expect to serve this many guests on each day. Okay, so step 1 is done. Let's go ahead with step 2 now. So step 2 is to create a menu item forecast, right? So we've got this guest item or guest forecast, but we need to convert it into how much of each menu item do we anticipate selling. Okay, so for question 3, it says using menu mix, items per guest, and forecasted guest count, forecast the number of menu items sold on each day of the week. Round your figures to the nearest integer. Okay, so we are going to take our guest count forecast and convert it into a menu item forecast. So we start with our guest count forecast. Okay, the problem is though is this is measured in guests, and our menu mix is based off of items sold. Okay, so it's not like each guest just consumes one item. Each guest on average consumes 2.43 items based on our historical data here. So we need to take our guest count forecast and scale it up into a total items forecast. And so we're going to do that by multiplying it by this 2.43. Okay, that then gets multiplied. That's all of the menu items that are being ordered. And now we can just multiply each of these by their respective menu mix in order to figure out how much of each item is going to be estimated to be sold. Okay, so let's think about each of these references. As I pull this down and over, I do want this to move down, but I don't want it to move over. So I need to throw a $sign in front of this F reference. Okay, down here, I want this to stay both on the row and column. So let's throw a $sign in front of the B and the 18. And then down here at the bottom, I want it to move over, but I don't want it to move down. So let's throw the $sign in front of the 29. Okay. It also says that we need to round to the nearest integer. Okay, so let's go ahead and do that. So if we come back into our equation here, let's just put round out front and close our parenthesis here. Okay, now we can copy that down and over through Saturday. Oh, looks like I went past Saturday. Here we go. All right, so coming back to our PowerPoint slide here, we created our daily count, our daily guest forecast. We have now created our menu item forecast. Okay, we need to now convert that menu item forecast into production items. Okay, so the items that we prepare in advance in preparation of opening up our food truck are all listed down here on the left. Okay, these do not correspond neatly with the items that we actually sell, right? So multiple hot dogs, for instance, are going to use an all beef hot dog. So we need to convert this from menu item forecast into a production item forecast. Okay, so let's read question 4 here. Create the production item forecast using the menu item forecast in question 3, the production item key to the right, and the notes under each item. These values are the expected consumption given the sales forecast from question 3 and do not account for variation in demand or menu mix. Okay, so once again, we're creating a production item forecast. Our goal is to then convert that into production pars, which also include a margin of safety. Okay, but it's going to be based off of these values, which is what we actually expect guests to consume. So we wouldn't ever prepare precisely the amount that we expect guests to consume, because then by the end of the shift we would have ran out of half of our products. We would have had most of our products for the entire shift, but then towards the end of the shift we'd start running out of products, and all things being equal, we'd have about half of our products still stocked by the end. Okay, so we need a little bit of extra product, and we do that by factoring in a margin of safety. Okay, we're not going to tackle the margin of safety here in question 4. We're going to address that in question 5. Here we're just trying to figure out exactly how much product we would need to serve on an average day. Okay, so I referenced you here to the right because it tells you how things are counted, okay, which we'll need later, but right now we particularly need to know which menu items are being used in each production item. Okay. All right. So for this first one, for the beef hot dogs, they're used in the New York dog, Atlanta dog, Chicago, Detroit, and Newark. Okay. And they're counted by the each. So let's go ahead and add all those up. So we come on up here and we do New York plus Atlanta plus Chicago plus Detroit plus Newark. Okay, so we skip San Francisco and Sonora because they weren't included, right? San Francisco and Sonora use this other hot dog. Okay, so that looks good. Next we have the bacon wrapped hot dogs, and these are used in the San Francisco dog and the Sonora dog. All right, we've got all of our hot dogs, which are counted by the each. Let's go ahead and drag that equation on through Saturday. Next up, we have the beef chili. Okay, beef chili. And the beef chili is used in the preparation of the Atlanta dog and the Detroit dog. So let's add together the Atlanta dog and the Detroit dog. Okay, what that gives us is how many hot dogs we're going to prepare. Okay, if we look though over here, beef chili, we're doing beef chili, it's counted by a full third pan, so a 4-inch deep third pan. Okay, so this is a recipe that will fill a third pan. Okay, and so I like knowing how many items would use this isn't particularly helpful. I've got to take it a step further. So in the introduction I said that you would also need to know some information about each of the items. So if we hover over beef chili here, we can see that a 4-inch deep third pan holds 64 servings. Okay, so what I need to do here is to put this all in parentheses and then divide it by 64. That will tell me that I need 1.25 full pans or third pans of chili prepared. Okay, next is the Atlanta dog. So let's go get the Atlanta dog. Okay, there we go, 31. But then once again, we're going to have to divide that by 42 to convert it into the number of pans that we need. So let's divide by 42. So we need 0.74 pans. Okay, next is jalapeno salsa. This has 144 servings in a pan. Let's look at what it's used in, just the Sonora dog. Okay, so let's go get the Sonora dog right here. And once again, we're dividing that by 144. Okay, next is Neon Relish. Has 112 servings. and it's used in, I think, the Chicago dog. Yeah, Chicago dog. So Chicago dog divided by 112. Double check that. Yep, that looks good. Pinto beans, that's used in the Sonora dog, I believe. Yep, Sonora dog. Okay, let's see what we should divide it by. Looks like 36 servings per pan. So divide by 36. Okay, sauteed onions, there's 56 servings in a pan. I believe it's just using the Newark. Yep, the next two are Newark. So let's go Newark here and Newark on the next one as well. Okay, for sauteed onions, it gets divided by 56. And for sauteed peppers, it gets divided by 52. Next is shredded cheddar cheese. Holds 60 servings. It's used in the Detroit dog. So Detroit dog divided by 60 servings. Last is sauerkraut. I believe that's the New York dog. Yep, New York dog. There we go. Let's see how many servings there are. There's 56. Steamed sauerkraut, so divide by 56. Okay, there we go. So we can now copy all of these equations over through Saturday. And last off, we have to do the produce section here. So produce, the first item is used in Chicago dog, Detroit dog, and Sonora dog. So Chicago dog plus Detroit dog plus the Sonora dog. Let's put all that in parentheses. Okay, and see what we need to divide it by. So there's 160 servings in a pan, so let's divide it by 160. Okay, shredded lettuce, 32 servings in a pan, and it's just used in the San Francisco dog. Okay, so let's go grab the San Francisco dog here. And once again, we're dividing that by 32. Last off, we have tomato slices. There's 100 servings. Okay, and that's used in Chicago, San Francisco, and Sonora. So Chicago, San Francisco, and Sonora. Close parentheses here. Okay, and divide by, I think it was 100. Let's go double check. Yep, 100 servings per pan. Okay, now we can copy these on over as well. All right. So that's by far the lengthiest, most subjective part of the assignment. It's the hardest part of the assignment, is routing all these, okay? And really this is doing a lot of the heavy lifting. It's converting menu items into prep items, right? When we're getting ready in the morning for our shift, we don't prepare menu items. That's done every time we have an order placed. We prepare prep items. So this is taking all of those sales figures that are measured in menu items and converting it into actual prep items. Okay. Question 5, it says, using the production item forecast in question 4, create production pars, which are labeled par in question 6, by adding a margin of safety of 30%. This margin of safety will help account for variation in guest count forecasts and menu mix forecasts. Okay, so what happens is we don't know exactly how many guests are going to show up. We've put together a forecast that we feel like is pretty accurate, but there can be some variation in that forecast, and we could have more people than we expect show up. Also, so that's the guest count variance, but we also have menu mix variance. So based on historical performance, okay, 10.81% of items ordered are New York dogs. Well, what if on a particular day people order an unusual amount of San Francisco dogs? Okay, that could boost menu mix for that item, and if we don't have enough items prepped, we could run out, even though our guest count forecast could be pretty accurate. So we're accounting for variations in both guest count and changes in menu mix that deviate from our averages. Okay, so our margin of safety is meant to help ensure we have enough product for both of those variables. Okay, so we need to take whatever we forecasted up above, round up the meat items to the nearest tenth of a unit, and round up everything else, or I'm sorry, round up the nearest meat items to the nearest unit and everything else to the nearest 10th unit, and add in this 30% margin of safety. Okay, so for meat items, we're going to come up here. We're going to start with our all beef hot dog. Okay, we're going to times it by 1 plus our margin of safety. Okay, that needs to go in parentheses. Okay, and then that all needs to be rounded up. And since it's a meat item, we're rounding up to the nearest integer or nearest item. So there we go, 307. We'll do the same thing for the bacon dogs, and then pull this across here for each day of the week. Okay, let's now go do it for the chili. So we're going to use round up, and we're going to come up here to our production item forecast and times it by 1 plus the margin of safety of 30%, close that parenthesis. Okay, and then we're going to put a comma, and since we want it to round to the nearest tenth of a percent, we need to put a 1 here as the second parameter for roundup. Okay, 1 is 10th decimal place, 2 is 100th decimal place. Okay, so that'll round up, so we get 1.7 as our production par. Okay, now we actually expect to go through 1.25, so if we prepare 1.7, we're thinking that's probably sufficient extra beef chili to make sure we don't run out. Okay, we can go ahead and copy this down and copy it on over. And we can copy this row here and paste it down here in produce as well. All right, question 6, it says populate the par figure below using the values calculated in question 5. Using the par and the on-hand amount, calculate the amount of daily production and the product usage. Use the tips found in the item description to determine the appropriate production amount. Okay. So what we're going to do here is just grab our par from up above. Okay, so here's our par. I'm going to reference what we created right here. Okay, and let's go ahead and copy this, and we can go down through all of these cells. I'm just holding down the control key on a PC or the command key on a Mac, and then I'm going to come up to edit, paste special, and formula only. Okay, so that looks great. I've got all of my pars populated, and actually I can populate my pars for the entire week because I already have all my pars calculated for the entire week. So let's come in here and take this whole column here and go ahead and paste it into each of these par fields. Okay, and that'll just bring down our pars. So how this usually works is at the first of the week, the sous chef or the executive chef will sit down and create these production pars for the upcoming week, like at the beginning of the week, before the week has even started. Okay, and then the staff will come in, measure how much product is on hand each day, and use that to calculate the amount produced. Okay, so if we flip back here to our steps, just to kind of give a brief overview of where we've been and where we're headed, we created our daily guest count forecast. We converted that into menu item forecasts and then into production item forecasts. We then used those production item forecasts with a margin of safety of 30% in order to determine the pars. Okay, that's what we did in the previous question. Now we brought those pars down into the actual prep sheets, and now we are counting the prep items daily and then determining what our production needs are and completing the production cycle. Okay? Okay, now we're ready to calculate the amount that we need to produce each day. Keep in mind that we need to prepare items in batches that make sense for this food truck. So for instance, once we open a package of hot dogs, we're not going to just prepare the amount of hot dogs that we need. We're going to go ahead and prepare an entire package of hot dogs once it's opened. So for the all beef hot dogs, that just means opening a package and putting it into a third pan. Okay, for the bacon wrapped hot dogs, that means opening a package, wrapping each of them in bacon, maybe even partially cooking that bacon in the oven, okay, and getting it all ready. Once again, we're going to do that with a whole package of hot dogs. So here in this, if we hover over this, it says that production quantities should be divisible by 24. That's the quantity in a batch. Okay, and when determining how many batches to prepare, figures should be rounded up. Okay, so what we're going to do here for the produce column is we're going to do our production calculation, which is 307 minus the amount that we have on hand. So we need 307 by the time production is all finished, and we have 112 on hand. So that's why we're subtracting it, because we don't need to prepare that amount. Okay, so what we have as of right now is exactly how many hot dogs we'd need. However, we need that to be rounded up to the nearest quantity of 24. So we're going to do round up. Okay, and we're going to take that value that we just calculated and divide it by 24 to figure out how many batches of hot dogs we need. And then we close that parenthesis, and because we're counting things in actual hot dogs and not batches, we need to then multiply it by 24 again. Okay, so that'll give us a number that's divisible by 24. All right, so that works great for hot dogs and bacon wrap hot dogs. Okay, let's now do it for beef chili. So beef chili, okay, it's prepared in pans that contain 64 servings, right? And if we prepare this recipe and we need less than a pan, we're just going to go ahead and prepare a full pan. So we're going to once again use the roundup function here when determining how much product to produce, because we're always going to produce a full recipe. Okay, so let's go ahead and use equals roundup. Okay, and we're going to do our par minus the amount that we have on hand. Okay, and go ahead and close our parenthesis. All right, so as we pull this down, you'll see something kind of funny here. We have two values that are negative. Okay, and that doesn't make sense. What's going on there is we have more product on hand than we need for the day. Okay, so it's saying if you have so much product on hand, you could give some of it away, hence the negative value here that's getting rounded up. Okay, we don't want it to do that. If it happens that we have more product on hand than we need, we just want it to say don't prepare anything, prepare 0. So we can create a little if function that does that. So if, okay, the amount on hand is greater than the par, the amount that you need, then go ahead and prepare 0. So we'll just put in a 0 there. If that's false, then we must need some product, so go ahead and use the formula. Okay, there we go. So now if we copy that down, it'll put zeros into these fields that originally had negative ones. Okay, and we can copy that on down through produce as well. So here we can see we're not preparing every single item each day, right? There are a handful of items that are not getting prepared on Tuesday. All right, so this is the cycle we would go through on a daily basis. We come in, we have our par set early on in the week. We come in and check how much product we have on hand and determine how much we need to produce. We'll go through and we'll actually produce all of these quantities, fill up the line, get it all ready, and we'll work the shift, use all the products, and then we'll come in the next morning and start the process over again. So coming in the next morning, we're going to have to count how many products are on hand in order to then determine how much we need to produce. Okay, so that's why you're not seeing all of these on-hand amounts, is because you won't know until the next day, right? So I went ahead and just gave you what the on-hand amounts should be over here. So we'll go ahead and just paste them in as we're working on this so you can see what a kind of realistic scenario would be like. Okay, so we come in the next morning, we count the new numbers that we have on hand. Now we're able to go ahead and calculate how much we used. So once again, this is a variation of just the cost of goods sold formula, right? So remember that's beginning inventory plus purchases, or in this case, the amount that we produced. Oh, I'm off a column here. Beginning inventory plus the amount that we produced, okay, minus the amount we have on hand, like the ending inventory. So that's the on-hand amount the next morning. Okay, we can use that to then calculate how much product that we used. We can copy that through all of these. Okay, great. So this is very useful information because we can compare that with how much we should have gone through based on the sales report to figure out if we're missing any product, if we should have went through less product, okay? And we're actually going to do that in some future steps. So we'll kind of hold on to this and come back to it. Okay, now we're ready to start this cycle all over again for Wednesday. So we have our PAR that was set at the beginning of the week. We come in and count the inventory for each of these production items, and now we're ready to calculate how much to produce. We can, in fact, just copy the contents of this cell, since we did all those calculations right over here. Okay, and it's going to do all those calculations for us. All right, so we go through, we produce all these items as specified here. If any of these varied, like if we ended up producing any of these amounts different than what we had planned to do, we would want to update those and overwrite the calculations here with what we actually produced. Okay, we did everything divisible by quantities on how we purchase it, so it should be fine, but if needed, we could update these fields. So now we come in Thursday morning, we check and see how much product we have on hand, we walk around through the walk-in, through dry storage, through the cook's line, and count up everything, and that gives us these new on-hand values. Okay, and we can now calculate how much we used. Once again, that's a variation on the cost of goods sold formula, so amount on hand on Wednesday plus the amount that we produced, which in accounting would be purchases, but we can do all these same calculations in units. Okay, and then we're subtracting the amount that we had on hand the next morning. Okay. By the way, we could have also just came over here to the use column here and just copied all of this and pasted it here. Okay, and that looks great. So for the produced, we're going to take our PAR, subtract our on hand, go through that same process. We already have all those calculations right here. So let's just copy this and paste it right here. Okay, we go through the whole production cycle, come in the next morning, we're ready to count how much we have on hand on Friday morning. We count everything up. Okay, let's paste that there. This is what we counted up. And now we're ready to, once again, calculate how much we used from the day before. So we can just highlight all this, copy it here and paste it here. Okay, and once again, we can use the same approach to calculate what we need to produce. Right, so we're just following this cycle over and over again. I've put it all separate because realistically, you wouldn't know each day how much product you'll have on hand in future dates. That doesn't make any sense. So this is the type of process you would actually go through. Okay, once again, we can then calculate how much product we used and then how much product we need to produce. Okay, so that's what the production process looks like. You'll notice on slower days, we're not preparing every item, right? Here, there were 4 items that we didn't need to prepare. Then on a nice busy day, though, like a Friday or a Saturday, every item is being prepped and oftentimes multiple batches, okay? All right, here's some information that'll be used in question 7. So here we have a point of sales report. What we did is we went into our point of sale system. And for a food truck, this would probably be like an iPad that has some kind of an app uploaded onto it, and we take payments from guests using the app and the iPad, and then at the end of the week, we can export a sales report. Okay. Now I only exported Tuesday through Friday because we don't In order to do this full analysis, we would need to know the on-hand amounts for the following Tuesday. We don't have that, and so we won't be able to do the analysis for Saturday. So I only exported a sales report for Tuesday through Friday. Okay, so here we can see all of our unit sales, and we could actually compare this to what we had forecasted back at the beginning of the week. So for instance, Chicago Dog, we actually sold 71 of them. We could cruise up here to our forecast, okay, and Chicago Dog, we'd estimated that we would sell 66 of them. We ended up selling 71, so our forecast was pretty close, but it's not perfect, okay. So this is our actual sales record. Keep that in mind, right? After we're actually done with the week, we can go back and see how much we ended up selling and see how accurate our forecasts were. The other really cool thing about having a unit sales export like we have here from a point of sale system is that we can use that data to determine how much product we should have gone through, like a theoretical amount that we should have used based on our sales, okay? So to do that, though, similar to how we did up above here, where we took these forecasted menu item sales and converted it into actual prep or production items, okay, we would have to go through the same process, right? To take these values and do all the routing like we did here. Let's see here. Here's our routing, right? To figure out how many hot dogs. This is what we did to figure out how many hot dogs we thought we would need. Okay, now that we have the actual unit sales values, we can use the same process to figure out how many hot dogs we should have used, how many pans of beef chili we should have used based on our actual sales. So super cool process. We, of course, would prefer it if we didn't have to go through that whole process again of converting menu item sales down into prep or production items. So I've gone ahead and I've formatted in such a way that we can just copy, okay, we can copy the cells from above and just paste it down here below. Okay, so let's go ahead and do that, and then it'll do all the routing for us. So we're going to come up here to question 4, and we're going to grab all of this field here, okay? So Tuesday through, let's see, I guess we're only going through Friday, so let's do Tuesday through Friday, and we're going to go ahead and paste it down here, okay? So what you'll notice now is because everything was in the same place, we can see like beef chili is used in the Atlanta Dog and the Detroit Dog, okay, and it's taking these items, adding them together just like we did up above on the forecast, but now it's using the actual unit sales. It's dividing it by 64, so this tells us exactly how much chili in this case we should have used, or exactly how many hot dogs we should have used based on our actual sales record, okay? This is really powerful because we can compare that with the use column that we have right here, right? This is our use column. We can compare those two and see how, like, what product is missing and try to figure out why. Okay, before we do that, let's go ahead and total everything up. So equals sum. I'm going to add up all 4 days. And we're going to do the same thing just for all these fields here. Okay, now this looks like it's kind of rounding too much. So let's go ahead and just show more decimal places here. That's great. So based on our sales report, okay, based on how many products we actually sold, this is theoretically how much product we should have used each day, okay? So we've got our theoretical amount, okay? Now we've got our actual amounts. Remember, actual amounts are based off of inventory changes and how much product was produced. Well, that's exactly what we already calculated up here in question 6, okay? So I'm trying to find how much product we actually used. Well, we have it right here, okay? So I can then take this value and copy it through here and through here, okay? And same thing here, except I want to show more decimal places, right? So let's copy that now and paste it all over here and here, okay? Oh. There we go. Let's do some sum formulas. That looks great. Okay, we can get rid of our decimal places on that one, paste it there. Okay, increase our decimal places here, copy that down through there and through there. Okay, so based on this, we actually went through 6.4 pans of chili. Okay, that's great to know. That's based on measuring our actual inventory and how much we produced. Okay, and based on this up here, based on our sales report and converting all that, we should have gone through 6.36 pans of chili. So that's great. We can compare the two and see if we're missing any product. I mean, that's super close. 0.04 pans off on chili. We would definitely not be concerned about that. So we could go through and compare every item, or we can go ahead and just do the math. And that way, if anything's not zero or not close to zero, it'll pop out to us. We don't have to look at every item individually. Okay, so let's do that. So to calculate the variance between the two, we're just going to do our normal variance calculation, which is actual, which we have here in question 8, minus the benchmark, which is our standard amount based off of sales. It's our theoretical amount, right? Okay, so there we go. We got 2. Let's go ahead and calculate the variance for all these. Okay, let's copy it again. Oop. Okay, and then we're going to want to show additional decimal places here. Okay, so let's make some observations. Anything significant we want to make note of. So on Tuesday and Wednesday, it looks like we're missing 2 and 3 whole units. So what is that? Well, we're missing 2 hot dogs. A positive variance means we used more than we should have. So we used 2 extra hot dogs on Tuesday and 3 extra hot dogs on Wednesday. These are hot dogs. We're talking about cooking hundreds of hot dogs in a day. I'm not going to be super concerned about a variance of 2 or 3 hot dogs. Okay. Now, if that's happening every day, then maybe we need to look at our procedures again, make sure if like somebody changes their mind that we're still ringing in the new item and then comping off the old item that needs to be discarded. So we might look procedurally on how we can tighten up those variances, but we're not going to be super concerned. The item that does kind of jump out to us as being excessive is these bacon wrapped hot dogs, right? So it looks like, wow, we're missing 24 hot dogs. Well, if you recall, there's 24 hot dogs in a package. So maybe when they were going through production, they went to prepare those hot dogs and they ran out of hot dogs. And so they just prepared the packages that they had and were short a package. Maybe something like that happened. Maybe a whole pan of hot dogs just wasn't counted. It was sitting on the shelf. Maybe there were like 3 pans of hot dogs and they only saw 2 of them, which made us show that we're missing 24 hot dogs. There's probably something fairly benign with why these hot dogs are missing. We would definitely want to look into it and see what happened. And if we had Saturday's data, it's quite possible that this value would correct itself the next day. So maybe we're short 24 here, but then we're over 24 the next day. Okay, if something happened like that, then we could confidently know that it was probably just a miscounting. Okay, so not super concerned about anything here. Maybe want to watch our hot dogs a little bit on Tuesday and Wednesday. We could check and see who's working and just remind them to make sure they ring in items that are missing. Could be that they ate those hot dogs or gave them away to a buddy or something like that. So if theft's happening, we want to be concerned about that, but we shouldn't automatically assume that theft is happening. Okay, I'm going to get rid of 1 decimal point here. Okay, so everything is looking pretty good. Nothing in particular is jumping out to me too bad. I do have a total 0.4 pan variance on cheddar cheese, so it looks like we're just putting a little bit too much cheddar cheese on some of our hot dogs. Okay, could be as well that maybe I have an employee working that likes snacking on the cheddar cheese. That would be something we'd want to address, not only from a cost standpoint, but from like a sanitation standpoint. We don't want people sitting there in the industry, we call it grazing, just sitting there kind of eating the food off the line. Okay, so maybe something to kind of just start watching for as I'm working, just seeing if what's going on with the cheese. Maybe they're overportioning it. This one's kind of interesting, the diced onion. I have a negative variance. Okay, negative variance means that you used less product than expected. Okay, so it's pretty unusual to have a negative variance. The only time that that really comes up is if employees are putting too little product on. Okay, this is diced onion. Maybe the employee that's working during certain shifts thinks that less onion should go on the hot dogs. So that's something we would want to address with the staff, make sure they're following the procedures. And if it truly is just too much onion, then maybe we can rewrite the procedure with a lower amount and have that conversation with our staff. Okay, so no super major concerns here. We want to look into why this was off by 24. It looks like something wasn't counted. And that's kind of the only significant red flag here. Okay, now we did this example with hot dogs and really cheap items. It wouldn't be super consequential if we're missing some items here. But if this was instead a fine dining steakhouse, and instead of hot dogs, we're talking about ribeye steaks and filet mignon and things like that, then you could see how this could be much more consequential, more of an opportunity of theft, and people would benefit a lot more from stealing. So something like this could be really helpful in tracking our product and making sure it's not going out the door. This isn't just a theoretical exercise. Restaurants do these kind of things. There'll be variations from how we've done it here, but the principles are the same. It's very common for restaurants to track their expensive items and make sure that they don't go missing. Okay, that theft can really be consequential. The products themselves cost a lot of money, and we want to guard against any theft of the items, such as steaks and expensive fish items and seafood, stuff like that. But then also it could be that something's missing from a sales perspective, right? So if you have a server that's stealing items, like stealing revenue from you, it'll be manifested oftentimes in missing product. So if I'm missing 5 hot dogs between these 2 days, well, it could be that one of my employees told some guests, oh, that'll be $5 for your hot dog, and they gave him cash and never rang it in, and they're just pocketing that cash. Okay, so the actual product cost on these hot dogs might only be like $1, but when we factor in the fact that it could be missing revenue, then it can be much more consequential. Before we wrap up this presentation, I just wanted to talk about how this can be utilized in industry. Okay, you'll see all different kinds of restaurants doing different processes, and usually some kind of a variation of this process is used at fairly high volume restaurants. Small restaurants, maybe they won't go through as formal of a production process and really going through and calculating PARs and things like that. But they'll keep an eye, they'll have like a line check form and have a way of prioritizing prep of different items and organizing prep. Okay, but in larger, higher volume restaurants, they will do something like this. Now, they might not automate the calculation of production PARs like we've done here. They might do it kind of through a more manual process, but they'll use typically something like this. Now, that being said, just because industry doesn't widely adopt practices like this, certain operations absolutely do, and it gives them a competitive edge. And you coming in as a student, maybe you lack some of the experience that some of your colleagues has, but what you're getting is a really great education with specialization in things like managerial accounting that can really give you an edge in the workplace. So in this example here, we worked through a pretty realistic scenario for a food truck that isn't super simple. I mean, it is simple, but not crazy simple. We still had to work through the whole scenario, and we did an entire menu, and we were able to do that in like 45 minutes. So if you were doing this for a real business, you could set something like this up likely in a day if you had a lot of the information at your fingertips. If it's a really complex menu, it would likely take you a day or two to do it. But the benefit is that once it's set up, I mean, think about how much of this you would actually have to update. Okay, you would come in here and you would clear out the on-hand amount, the production amount, and the use amount, and all that would be left in these forms when you print them would be the PAR amount here. Okay, and that PAR amount would be calculated automatically based on pretty much just the guest count forecast. Okay, so this whole menu mix exercise, you don't do that all the time. You might update that seasonally when there's substantial changes in guest consumption behavior, but these will stay relatively the same over an entire season typically. So you do this little exercise seasonally to adjust for changes in consumption behavior, but really you're mostly just going in and updating like this value here. What was your previous year's guest count? Just update that. If you're still increasing about 8% every week, you just leave that. So that's one update here that drives all of this. Updates automatically. This is created automatically. All of this is created automatically then. Okay, so pretty amazing. Everything is basically getting created and pushed into each of these columns just based off of simply plugging in an updated guest count for the upcoming week. Now, if the daily share is going to change a lot, you might have to manually kind of override some of the calculations or boost some of these days up, adjust it here a little bit. But really, you're just kind of making some changes on a weekly basis in one spot here, and your production pars are being updated automatically. That's really cool and valuable. Okay. The other part of this, if you want to do the full analysis, the variance analysis, the only other thing you would need to do is come back in after and fill in this use column, okay, with using your actual production sheets that will have been filled out on pen and paper during the week. So you come in here and fill this in, and then you export a file from your point of sale system and update your unit sales amounts here. This, if you used VLOOKUP functions and things like that and just had it reference a separate sheet that you're importing and just paste it right onto that sheet, you could automate this process as well. Okay, and then it would do all of your variance for analysis for you automatically. I mean, that's incredibly powerful to be able to put together a really accurate production par for the week, production pars for the week, and then be able to do all this variance analysis is really valuable. So a lot of work to set up, not crazy amounts of work, but a good amount of work. Requires a decent skill set to do so. But you've now done it in this sample problem, and you'll do it again in the day in the life. So if you could apply this in a real restaurant, it could save you a lot of money, save the restaurant a lot of money, ensure that the product is fresher, track theft better. I mean, this is a really effective controls tool. So I hope you found it helpful. Have a wonderful day.